There's another option for converting ToFSIMS data, and it's on the SIMS toolbar, which is available from the View menu. And if we select this toolbar button here, a dialog window that displays a directory, and in this case we've got a directory containing data with a txt file extension. And if I open this file in Notepad, you can see that this is the same format as was previously used, using the .ion conversion filter to convert individual files. Now this case, what we're going to do is we're going to convert not one of these files but all of these txt files, and we'll do this using an instruction of the form, we'll call it new file name. And now the important thing is to enter .ion, and the .ion instructs Casa to look in the current directory for all txt files, and it will then convert and enter these new files into an experiment frame. So it's processed the directory and it's come up with 6 files, so there's 6 txt files to process, and we say yes to continue. So the data file has been converted and each one has been entered into a new VAMAS block. So we can overlay these and see all of these spectra plotted using a time plot. If these data have valid time to mass calibrations, there is another way of processing this directory. Let's just see what happened when we did process the directory with the ION. Is that what happened was the txt files, which are about 6 megabytes, have been converted to VAMAS files that are about a megabyte. But we can process these data an alternative way based on the mass calibration within the files, and we can type in a file name dot, and this time AMU, meaning we want to convert the txt files in this directory. When we use AMU as the extension to the name that we wish to call the file, then when these txt files are processed, they will be converted to mass VAMAS blocks. So again, it's found 6 txt files, even though the VAMAS files in the directory, it's found txt files, so it's counted the number of txt files, and these are the ones that will be converted. So pressing yes will cause the conversion to start. So the file now looks like 6 rows, one for each one of the data files, and these contain mass spectra. So if we overlay, for example, the sodium peaks, we can now see that the mass calibration has been used to align these peaks. And the reason these peaks are offset is because the mass calibration wasn't exactly the same for each one of the files when converted. If we go back to the wide form of these data, then let's have a look at the sodium. So you can see that each one of these files originally had a different mass to time calibration. So this is now being plotted as a time plot, so you can see that the peaks are offset in terms of time, and what we would need to do is recalibrate these before converting them if we want to get these sodium peaks to line up in the mass form.